Hey there, CS210 students. So in Chapter 5, we are going to talk about functions and defining them. So from your previous programming classes, you've definitely written functions. You might have called them methods, but the same ideas are going to apply for the most part here in C++. So keep in mind a function definition in C++ will contain the potential data type that it's going to return, its name, parentheses where we can potentially add parameter values, and then a block of statements. And remember, in C++, everything is enclosed in curly braces as a block of statements. So real quick, easy method right here. They've got a method called calculate pizza area. It's got a diameter, radius, area. They've got the area, the value of pi in here. So they're going to set the diameter of the pizza to be 12. They're going to calculate a radius. And then the area of that pizza is pi times radius squared. And then they're going to return that pizza area right there. So very similar to other methods that you've probably seen. Again, this didn't take any parameter values. It calculates and then returns that value. So this can be used anywhere, so we can use it in this main method here. So they're going to calculate the pizza area. And then one thing that's kind of wonky about this is, it defaults that it's a 12-inch pizza here. It'd be great if this had a parameter, where then it doesn't matter what this is. We don't set it in here. We take that value and we plug it in right there. So again, the idea with functions, they may return a value. So if that's the case, if we want them to return a value, again, we specify that as part of the signature. So here we're going to return an int value, and then we have to return an integer inside this method. My rule of thumb is that typically I only want to have one return statement total. So here, this is a really trivial exercise, but I typically save to a variable, so it might look something like this. So I would rather write it like this, int result, and then result equals num2 square times num2 square, and then I'm going to return the result. The advantage in doing this is we can put a debugger in here, and before we get out, I can see what this variable contains. Otherwise, I have no chance to really see what this contains using a debugger. So when this method's called, we also here have a parameter value. So the parameter, we have to specify the data type and then give it a name, and then we can use that variable inside this method. So then when we call it, we have to provide it a value. So we gave it a 7, and then it's going to perform 7 times 7, and this come back as 49. Now, one thing that I don't like is that they are naming their functions with capital letters here. This should be camel cased, where it starts with a lowercase and then uppercase for each new word. So if Zybooks requires you to create a function, then you need to create it using the rules. Otherwise, if it is anything else, this should be camel cased, not starting with an uppercase. Again, they go into some more detail. So here they cleaned up that calculate pizza area method. So they're going to pass in the diameter. So now this method works if we pass in 12, or we can pass in 16, and we get a nice result here. Oh, by the way, I really like that this method is very concise. It does exactly what it's supposed to do. It's just simply calculating the area of this pizza. And then this could be reused just about anywhere. One thing I don't want to do is I don't want to have CIN and COUT methods inside this method that then couple it to a console application. So I don't want my methods to do anything other than the things that they're supposed to do. Now, if the method is designed to display output and it's going to only be called by like the main method, then that's fine. But if I'm not being called by the main method, I don't really want to display any output or perform input operations. We could take it a step further, and so now we're going to calculate the pizza's volume. So to do that, not only do we need the diameter, but we also need the height. And so now they're going to calculate the volume. So that is the area of the pizza times its height. And so now we have two values that we have to send to it. And you can see here, they've got a 12-inch diameter pizza with a 3/10 height, same diameter pizza, but now it's an 8/10 height pizza. So again, we can use multiple values if we so choose. And I think that's it from this section. Yep, so let's move on to the next one. So reasons we want to define functions, a couple things. One, it improves program readability. So we've got a method here that's going to calculate steps to miles. So we take in the number of steps, we calculate how many miles that is. Great usage right here, okay? So great usage. Then we can come down here and we don't have this code right here in the output. It doesn't make any sense to do that. So we can kind of declutter our code, define the methods, and then we can call them when they're needed. So one thing is it improves program readability. We know exactly what this is doing here. Another thing, I'm trying to think if it's in this section. It's going to be in the next section, is that we can make our code testable, but also we avoid writing redundant code. So if I have a method that calculates the area of a pizza, I don't need to perform that action multiple times. So right here, you can see they got the exact same code here as they do here. So it's much cleaner to call the calculate area method rather than calculating things multiple times. That falls underneath the principle of dry, don't repeat yourself, DRY. So anytime you are copying and pasting the exact same code and just changing some values, write a method. They kind of go on with some more methods throughout the chapter. So your functions, they can have decision structures inside of them, not a problem. Um, they have a better example where they use constants. So up here, these are just magic numbers. Nobody knows what they are. Here, they've at least declared some constants, which makes the code much more readable as we go through it. So anytime you got magic numbers, declare them as a constant, so that way it's a little bit more readable. You can also see that they did a nice job of providing documentation for it. So this right here, they shouldn't do this. They should pull this down here right in front of it, so we can kind of see what the method's going to be doing. So I had mentioned another nice thing about creating functions is that it makes your code testable. So we have a method here that's going to take original hours and original minutes, and it's going to convert it to hours, minutes to minutes. So I've got a method here that does some work. And what we can do is if I pass in values, I can here, they're manually testing what they're going to see, but we're expecting values and they're not correct. What we can do is clean it up by using an assert statement. So we can provide assert statements where we are expecting this method call to provide a 0, this method call to provide a 1, and so forth. And for the ones that were supposed to fail right here, when I run this code, this assert statement, if they're not correct, it's going to fail. So they're using an assert statement inside the main method. If you go back to project 1, I provided you a unit test, which is a separate test file, separate test project that you can then test your methods. So again, making a method that is very specific to exactly what it does, doesn't have any cout or cins, makes this very testable. Okay, so next section, we talk about some common errors. So a common error is if you ever copy and paste code. So you can see here they had a Celsius to Fahrenheit method. Well, we'll just call it Fahrenheit to Celsius and kind of swap some things. We're gonna have a converted temperature value, and they're got Fahrenheit value and Celsius value, and oh, look right here. They forgot to return the Celsius value. So very common issue when you copy and paste methods. So this section just kind of goes through that. Another one is you might be missing a return statement. So if you say that it's an int method and it doesn't return a value, most compilers are going to complain and it is not going to compile. Our compiler in Visual Studio does a little bit of helping. So if that's the case, if you forget the return statement, and if I catch it, then it's going to be a doc there. So make sure that if you declare a method that is returning a value, again, I like to declare this at the very top of it, and then as soon as I declare it at the top of the method, I come down here and I say return the feet total right there. Okay, so that should all really be review from your Python and Java courses. Now let's talk about some things that make C++ a little bit unique. And that's the fact that when I declare a method and I provide it parameter values, so I've got an int for the time, an int for the hour, an int for the minutes here, we say that these get passed by value, which means what happens is a copy of the value that it currently has is sent to this method. So what that means here is we initially have, so here's our method declaration. So here it is, here's our method call. And what we're going to do is we're going to create a copy of the values for these variables. So right here, we have one set of memory locations for each of these. When I pass it to this method, we actually just created a copy of those variables. So we really took up twice as much memory to handle that. Now, that's not a real big deal here. Most computer systems are very capable of handling lots and lots of memory. But again, it does have some overhead where it's going to copy the value and then pass that as a copied value. So we've got overhead with that. A nice thing about this is that if I make a change to the variable in here, so if I make any changes to these variables right here, those are not going to impact the initial variables that were sent, okay? So advantage is that we can do anything we want to the variables. It doesn't change what they initially started as. The drawback is we have to copy these variables. So a little bit of overhead, not too much. So a little bit of overhead and processing time as well as memory there. So to account for that little bit of performance hit, C++ lets you pass variables by reference. And so what that means is instead of passing a copy of the value, it's going to pass in the actual location of memory. And let's see if do they show it in here? Because this method right here is not, oh, sorry. Sorry, this right here is passing in these two variables by reference. And I know it's by reference because I see the ampersand. So to pass in the reference of the variable, we use the ampersand. And so now instead of passing in a copy of the variable, we get the memory location where we can actually access it very quickly. So advantages here is this gives us very quick access to the memory value. The disadvantage is we can actually change what the value contained. So if right here, whatever we assign this to, that's what user hour is going to contain. Same thing here. We are changing the value of this variable that got passed by reference, which is this variable right here. So advantage is we get very quick memory access. We get lower memory overhead. Disadvantage is you can now change the value of the variable. So be careful with passing by reference. Let's see here. I had to take a second there to figure out exactly what they were saying to avoid here. So take a look at this method. They pass in two values by value. And check this out, numVal2, they're going to do something to it here, and then they're going to return that value. So what they're saying is that we don't have to necessarily do that. What we could have done is we could have passed in numVal2 by reference, and then inside the body of that method, whenever I do something to numVal2, so if I set it to some value like they do here, I don't need to have a return statement because I've already provided the memory location and I have changed the value where the reference lives. So again, the advantage of doing this is that we get quick access to the memory, and if we do want to change it, we can. Me personally, I am not a fan of passing in something by reference and then changing its value. I think it leads to code that is difficult to debug. So I try to avoid that. So they're just going to talk more about what I just talked about right there. Okay, next section. So we can pass string and vector parameters to methods as well. Now, they do point out that you want to pass a string by reference. And again, the reason being is the advantage is you get direct access to the memory. You don't create a copy of the value. So with strings, creating that new reference is a little bit of overhead. So you can improve the performance of your method by a little bit by passing it by reference. And then you can see down here, they are passing the reference of a vector. Again, if we only have 8 values here, it's not going to take up a whole lot of memory. But if we had a vector that contains, say, 20,000 values, and we have a very minimal amount of memory available, we don't want to duplicate how much memory we are occupying. So they're going to pass in the vector by reference, and we just use it as normal in here. So it gets used by normal. You can see that they're not reassigning the vector to anything here, but keep in mind that you can do that. So one way to prevent it where you are reassigning a value is to declare the parameter with a constant keyword. So if I try to reassign vector values inside this method, the compiler is going to throw an error and it is not going to compile. So if we don't want it to be reassigned, we put it as a constant in the parameter list. Let's see here. Anything else that I want to look at in here? Nope, that's it. Now, they do talk about some methods that are passing in C strings. What a C string is, so original C programming language, not object-oriented, doesn't have a string data type. It deals with strings as character arrays. So we can pass in a character array, and then we can get the length of it, loop through it, and we can modify our character here, a character array. So kind of take a look here. We could also just pass in a pointer to our character array. Same exact thing. We'll talk more about pointers later on in our class. All right, big idea here. So we've been creating functions here, height in feet, height in inches. These are parameters for this method. Keep in mind that when you declare a parameter, and it's not by reference here, so there's no ampersand, this is a parameter. These variables are only accessible, height, feet, height, inches, are only accessible inside this block right here. So C++, like Java, is a programming language that wherever things are defined is the only place that they are available. So this variable cm per inches, that's available anywhere inside this file because it's outside of all the methods. only available inside this method here. This variable user feet, only available inside this method right here. So always keep in mind the scope of your variables. You definitely want to try to minimize them. Constants that are going to be potentially used multiple places. Let's see here. Did they use this multiple places? I think it's only used right here. It's not used down here. So really, those should have been defined inside this method. So minimize the scope, only put them in the location where they're actually being used. Okay, C++ can make functions have scope. And C++ supports the idea of defining what a function's going to be and then later on implementing it. So the idea with this is eventually we can define this function in a header file and then actually implement it in the C++ file. So here, this is a function declaration. We give it a return type, the name of it, and then this has the parameter values. Now, in the function declaration, I don't need to have actual variables here. I could just say double int int, but it does make it readable to know what parameters each ones are for. The actual definition could be anywhere in this file, so you can see it's down here. They've actually defined what this function does. So here it gets declared. Here it's getting actually implemented. So we've got the curly brackets. We're doing whatever work this method does, and it is returning this value. So if you look at my project one template, I definitely have some function prototypes where you declare them and then you have to later implement them. And then again, the big key idea will be in a section or two here coming up where we can define our own files where we could share those files with any project that we want. Now, some versions of C++ offer in section 14 here default parameter values. The idea here is that we might have some kind of default value for a parameter that we might want to use. So we might have some date styles here, 0's American, 1's European, and we're going to put a default value of 0 when we declare that method. Now, the way that default parameter values work is it has to be the last parameter or the last parameters. So if I wanted to put a current year, say of, I make this int cur year equals, it's right now 2023. I could not then just do int print style. So I could not get away with that. Once I declare a default parameter, then I have to make all of them have a default value. So again, the idea here is we can make it so that when we call this method, if I just want to use the default, I don't need to pass in anything. So a couple examples, here's where we're calling it with the current day, the month, the year, and then we're going to pass in a 0. Here we're going to 37-2012, passing in 1 for European. But this right here, I didn't need to pass in the 0. It would default to 0 right there. So again, a nice little nice to have if you want to, if you know that there's going to be some options and you know one of them is going to be used most frequently. All right, an idea from, again, Java that you should be familiar with is that functions can be overloaded. And what that means is I can have a function with the same name, just like we see here. And what has to be different is that their parameter lists have different types. So this is a print date with an int, int, int. This is same method name with an integer, a string, and an int. Now, if I tried to define two methods with 3 int values, doesn't matter what I call them, it will not compile. They must have a different signature, which means they have to have different data types. So a nice to have, you might have different formats of print date based on what information you have available to you. Okay. They do mention in this section, if we want to, we could actually check our parameter values for, logical correctness. If it's a month, it's got to be between 1 and 31. If it's not, then it's an invalid day. I don't like this method because it's violating the fact that this is printing out output, things like invalid day. I guess it's what that method is designed to do. I just don't like this. I would rather have a method that validates my method, and then I can just print it when I know that it's valid. But again, we can do some validations in here. Later on in our course, we would throw an exception instead of just printing this out. All right, here's where we tie together the function declaration and prototype. So we've done some include statements, but they were always include and then in the angled brackets because you've been including things that are in the standard C++ library. But it's possible for us to declare our own library of functions, and when that's the case, we have to include the file name inside double quotes. So we might have a file called myfile.h, and we include myfile.h right here. And so whatever methods are in there, so right here we have a function 1 and a function 2, we have declarations inside the header file. And then over in the implementation, we have to actually implement those methods, which should be, I thought they had it here, but they don't. But we would have to actually implement these methods in the code that has this. So it would look something like this. So we would include myfile.h, which means we would then have to provide a definition for this method. So we do something in here, whatever it is. And then int function 2, int param1, or I can call it whatever I want, value. I don't necessarily have to match that name right there. And again, I do something and I have to return something. I'm just going to return a default of 0. So myfile.h, here's the CPP file that would implement those methods. And then we could actually use whatever's been defined there. So take a look at project 1. I go through the details of this where we're going to define our header file, define our source file with the actual implementation. And again, here's where they go through that. So they've got the header file that defines some functions here. The CPP file implements those functions, and this at the top of it would need an include 3 ints facts.h. So that really needs to have at the top pound include 3 ints fcts.h. So that would be at the top of this file right here. And then here you can see that they are calling these methods right here. So the way that this all works together is the header defines what it's going to have. The CPP file for it implements those methods. And then over here, we're going to access the implemented methods right here. So the compiler handles all of that for us. Okay. Oh, by the way, header file guards should be put in place. What this does is it makes it that the preprocessor only handles this and does it one time as needed. So good practice is to guard every header file so we don't have this getting done multiple times. All right, so I know that's a lot of details to you. The idea of creating functions should be very similar to other programming languages, but now we've added to it some C++ nuances.